And question number 1 is another kind of question that I have a special name for it. Again, these ones that I give special names to, if it's because they happen a fair bit, and the name that I give them, if you can remember that, it also helps you remember some of the strategy you need to solve them. I think these are the scariest sounding questions when you read through them, just because there's a lot of information. They're actually not too bad and quite predictable to solve, but you read them and you've got two angles. Alpha's in standard position in quadrant 3, tells you something about alpha. Cos alpha is -3/5. A second angle, beta, in quadrant 2, and sine of beta is 1/3. And then we have to find the exact value. So anytime a question uses the word exact, that means that you're going to have square roots or pi or something in it, not rounding it with your calculator. Now the reason I call this a double triangle question is because we're going to draw two triangles. We have two angles, alpha and beta, so we'll draw one triangle for alpha and one triangle for beta. Set up your 4 quadrants. It tells us really nicely that alpha's in quadrant 3. So we can draw an angle in standard position in quadrant 3, draw the triangle back to the nearest x-axis, and label our reference angle for alpha. What do we know about alpha? We know that cos of alpha is -3/5. What does that mean for our triangle? Cos is adjacent over hypotenuse. We know this side is 3, this side is 5. A squared plus b squared equals c squared, and we can find out that this side is 4. That will tell us that sine of alpha is -4/5. And we could find tan of alpha and other things as well, but I'll just draw a straight line here. We want to find sine alpha plus beta. On our formula sheet, sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta. So the reason in triangle number 1 that I found sine alpha is I'm going to need that later on in my question. Triangle number 2, set up my 4 quadrants. We found out that beta is in quadrant 2. Draw an angle in quadrant 2. I can label my reference angle for beta. I know that sine of beta is 1/3, opposite over hypotenuse. A squared plus b squared equals c squared. And I can solve for that side to be square root of 8. Now I knew that sine of beta was 1/3. I can now figure out that cos of beta is equal to negative, because it's in quadrant 2, -√8/3. Double triangle question because you draw two triangles. Once you've drawn two triangles, you get information from those two triangles that you're going to use to figure out what they asked you to. They asked you to find sine alpha plus beta. We have that on our formula sheet. It's equal to sine alpha cos beta plus cos alpha sine beta. So now we use the information and we put it in to figure the rest out. Now, there's a very common error that happens in the next step. And that common error would happen whether I show you what to do next or whether I don't. You will make if you're going to make this error, it wouldn't matter what I teach you now, you're still going to make that error at least once. So now I want you to do the next step on your own. Do it in pencil if you feel like you might be one of the ones that does the error. Usually it's around 50%. 50% of the class makes the error. So I actually take statistics every year. So I'm going to come around once you've written the next line. What to do next? Here, put an equal sign. What do I write next? And I'll come around and do, hey, you guys are above average. 59% did it right, 41% made the mistake. So, what's the mistake and what's right? When plugging in things here, do we know alpha? Is there anywhere where it says exactly what alpha is? No. But we know what sine of alpha is. So the mistake is that people write sine of -4/5. You don't know alpha. But you know all of sine alpha is -4/5. So you replace all of that sine alpha with a -4/5. You know all of cos beta is -8/√3. So you replace all of cos beta. And so we just get numbers. Cos alpha is -3/5. And sine beta is 1/3. So the reason I do the survey like I just did is because if you're going to make the mistake, better to make it now than on the first quiz. So of the, like there's 41% of you that made the mistake. If I didn't do this, you would still make that mistake on your first quiz. Even if I showed you the right way, I found out that if I show you the right way without doing this, you'll make that mistake on the first quiz. Now, of the 41%, some of you will still make that same mistake on the first quiz, but it'll be less than 40%. And then some of you will still make the mistake on the test. That's the hope that by the time we get to the test, that mistake is gone, but it still might happen. You have to ask yourself, do I know what alpha is? No. If I wanted to find alpha, I'd need my calculator. I'd have to do cos inverse and find a reference angle and do all of that stuff. Now, I've just got numbers here. I can multiply things out. So this is equal to, whoops, I've got one tiny mistake in here. Put this negative in the wrong spot. -√8. Negative times negative is positive, so we have 4√8/15 plus a -3/15. In the end, you need to write your answer as a single fraction. So here I've got a common denominator. And there's my final answer. Sine alpha plus beta is 4√8 minus 3 all over 15. This is a single fraction. It's an exact answer because we don't have a decimal. And that's what the question was asking for. Questions for practice? Try a couple double triangle questions 8 and 13.